Okay, so think about this. You start building an agent, you connect it to a database, and it works great. Then you add an API. Maybe you want to connect it to a CRM, then you realize the agent needs to actually deliver results. So you send an email or post to Slack, or maybe write to a Google Doc. Every new data source needs its own authentication, its own SDK, its own configuration. Every output channel is another integration, and you as a developer are managing all of it. But here's the thing, this problem was solved 30 years ago. In 1992, John Donovan formalized three-tier architecture. So presentation is on the top, application logic in the middle, and data at the bottom. Every web application that you have ever used is built on this architecture. The key insight is that each tier is independent. You can upgrade or replace any tier without touching the others. So for example, you can change your front-end framework. The database does not care. You can swap out your database. The UI shouldn't notice it. Now map this directly to agents. The data tiers become the data source layer. We're talking about APIs, MCP servers, RAG pipelines. Anywhere raw information lives is your data source. The application tier becomes the processing layer. This will include LLM reasoning, orchestration, tool calling, the intelligence that decide what to do with the data. And then the presentation tier becomes the presentation layer. We're talking about Google Docs, Slack, emails, dashboards. So how actually results reach humans? In this video, I want to actually walk you through this three-layer setup and show you how you can build your own agents around it with the separation of concerns. And in the process, I will show you a practical example of this clinical trial tracker that I'm building, which is going to showcase these different layers and what goes in there. Okay, so let's talk about layer one, which is the data source layer. This is where the agent connects to the outside world. And the biggest story here is probably MCP, or Model Context Protocol, which was launched by Anthropic in November 2024. And the idea was that instead of building a custom integration for every data source, you build one MCP server and any compatible client can use it. Okay, so when you're designing the data source layer for your agent, here are some of the things you want to think about. First is data freshness. Is your data source static or it's real time? So for example, in the clinical trial database, updates happens weekly. For a stock price feed, the updates are going to be every second. So your architecture handles these differently. Second is going to be authentication, auth flows, API keys, secret management. Those are going to be different depending on the different data sources that you are connecting. Then you also need to worry about schema and structure. So unstructured documents and structured JSON have very different requirements, but all of them are going to be flowing into a single processing pipeline. So the question is going to be, how do you normalize all of these things? And the last thing to consider here is going to be reliability. When you are working with different data sources, each one of them have their own rate limits, timeouts, downtime. So your agent cannot just crash when a data source goes down. Let's talk about layer two, the processing layer. This is where the intelligence lives. In December 2024, Anthropic published Building Effective Agents, which is arguably one of the most influential blog posts in the agent space. Now in here, they define the fundamental building blocks, which they're calling augmented LLM, a large language model with three different capabilities. And these were retrieval tools memory. A retrieval gives the agent or the model access to external knowledge. Tool lets it take actions, and then you have memory, which lets it maintain state across interactions. So this is the atomic unit that every agent system is being built on top. Now in the blog post, they had a key principle. They said, consider adding complexity only when it's demonstrably needed. The idea is that you start with a simple agent and add multi-agent chaining, routing, orchestration if the simpler approach is not enough. Now, there's one more important thing in this layer, and that is skills that were introduced by Anthropic. Now, Anthropic has this way of introducing patterns that are adopted by the industry. The key distinction from MCP is that MCP tells an agent what tools are available. Agent skill teaches an agent how to use those tools effectively. So if you are doing anything in layer 2, which is the processing layer, you want to think about these 5 different. So the first and most important is going to be model selection. Not every task needs the most powerful model. So in this case, reuse reasoning models for complex decisions and faster models for routing and classification. Start with the most capable model to establish a baseline, then swap it for smaller models where results are still acceptable. Second is orchestration pattern. So single agents with tools work for most use cases. Again, simpler is better. Only add multi-agents when the task genuinely requires parallel specialized workers. Then we need to talk about context management. So as tool count grows, definition and results consume tokens. Now, Anthropic found that letting agent write code to call MCP tools programmatically instead of routing everything through the context window actually reduces costs and improve the accuracy of the calls. When you're connecting to an MCP server, you don't only have to worry about tool management, but also need to think about authentication flows. This is where today's sponsor Arcade comes into play. It enables secure agent authorization and gives you access to a large catalog of agent optimized MCP tools. More on them later in the video. Next is memory and state, right? So you probably have seen the pattern of session state within a conversation and long-term memory across conversations. Now, unfortunately, this is still an unsolved problem at scale. The last thing is cost, because every tool call, every token has a $sign associated with it. So when you're designing this processing layer, you actually need to consider all these 5 factors. Now let's talk about the last layer, which is the presentation layer. This is a human-centric if your results goes to the human. Now, none of the intelligence matters if the results don't reach the right people in the right format at the right time. Now, here's the interesting thing about MCPs at this layer. The same protocol that retrieves data can also write results. So an MCP server for Google Docs can both read existing documents and create new ones. And the protocol in the sense is bidirectional. At the presentation layer, think about some of these things. The first one is output format. And this depends on your audience. So is it going to be a dashboard, an email, or a Slack message? Because all of them have different constraints. Then design for the channel, not just the content. Second thing is going to be your audience. So depending on your audience, the type of data that you're going to present is going to be very different. A researcher wants raw data and citations. A manager, on the other hand, probably just wants a summary and a recommendation. You have same data, but different packaging depending on your intended audience. Then you need to worry about or think about timeliness. So real-time alerts versus daily digest versus on-demand reports. Each delivery cadence changes the architecture that you're going to be building. In some cases, you need to think about multi-channel. So the same insights often needs to reach multiple different places. So an example of this would be that you have Slack for teams, emails to your manager, a document for the record, right? And in some cases, you also want to have human in the loop. Now, the idea here is that you should think about when should agent pause and ask for approvals before acting. This is a presentation layer decision with processing layer implications. In the rest of the video, let me show you a practical example of putting all of this together into a single system, and I'll show you how to think about this integration. Okay, so here's the clinical trial tracker that I'm building. It's an open source project. Link is going to be in the video description. So the way it works is that you look for a specific disease or condition. Now, here is the data. It fetches data from clinicaltrials.gov through its free API. And then as a researcher, you can look at the details of different experiments. If you're interested in a specific experiment, you can create individual linear tickets for it. Those are going to be automatically pushed to your linear board. And the agent can help you keep checking the status if there are any updates to the experiment or study. All the data is also pushed to a Google Sheet for you to track. Let's talk about how all the three layers fit into the architecture of this clinical trial tracker. So layer 1, which is the data source layer. In this case, clinicaltrials.gov has a free public API. So we don't need any authentication. Now my MCP server wraps it with 4 different tools. And these are get search results for a specific condition, get detailed trial results, pull published results with outcome measures, batch check multiple trials for status change. Now, next up is layer 2, which is the processing and memory layer. This is where Arcade comes into play. The agent needs to remember which trial it's tracking. We're using a simple Google spreadsheet as a persistent watch list through Arcade's Google Sheet integration. Now, right now we have 3 different functions. We can save to the watch list, we can get the watch list, and we can update the watch list. Now, since we are using the Arcade memory tool, it's handled everything through their API. And then we have the orchestration logic. So there's a function in the code called run monitoring pipeline that simply chains everything together for us. It's a 6-step process where it reads the watch list from Sheets, check each trial against clinicaltrial.gov, pull full results for any trial with new data, generates an HTML digest, updates the sheet, and sends the email. So in this case, the orchestrator is interacting both with the data source layer and the processing layer. And then we have the presentation layer. In this case, the digest gets delivered to email via Arcade's gmail.send email tool. Now, for trials with the new results that need action, it can also create linear tickets again through Arcade's linear MCP tools. And then there is a local web dash built for interactive exploration. So here we have 3 layers and each is independent. The clinical trials data source does not know about Google Sheet, and the Google Sheet memory does not know about Gmail. And the beauty is that any of these can be swapped without touching the others. Now, let me zoom in on what Arcade actually does in this architecture, because it's more nuanced than it connects to tools. For this example use case, there are multiple OAuth flows, which happens in real-world applications. In our case, Google Sheets, Gmails, and Linear, each one of them have separate OAuth flows, which usually the developer would normally need to configure. You have to deal with redirect, client secrets, token refresh logic. Now, here's what it looks like with Arcade. There is a single Arcade API that you set, and you don't have to deal with all the other OAuth flows. Now, here's exactly how it looks like in code. There's this function for execute with OAuth. It tries to call the Arcade tool. If it gets permission denied errors, it will automatically trigger Arcade's authorization flow. Now, in this case, Arcade handles the OAuth pop-ups, pull for completions, and retries the call. Developer writes 0 OAuth code. Now, for our specific example, Arcade sits at layer 2 and 3, which are the memory and presentation layer. In our case, layer 1, the data source layer, stays direct because it doesn't need Arcade's auth infrastructure. Now, in this specific 3-tier pattern, Arcade is not trying to own a layer. It's solving the specific problem of authenticated tool access across layers when needed. So do check out Arcade, because that not only allows your agent to take actions on different platforms, but it also solves this very important problem of OAuth flows for authentication. Okay, one more thing. In the code implementation, you're going to see a section where the system is designed for Cloud Code agent teams. And I want to show you, if you're building a multi-agent system, how you can still think about different layers. Now, in this multi-agent system, we have the main orchestrator, or as agent teams would call it, the team lead. It sits in the processing and memory layer, and it delegates tasks to 4 different specialized agents. So first, we have the Scout agent that handles data retrieval. It's basically calling the clinicaltrials.gov API directly. Then we have the memory agent, which manages our watch list. It's going through Arcade to Google Sheets, and it sits in layer 2. Then we have the analyst agent, which basically pulls raw data from layer 1 and formats it for layer 3. And last, we have the dispatcher agent that delivers results. Again, it connects to Google Sheets, Gmail, and Linear via Arcade. So if you're designing a multi-agent system, you can still think of it in terms of this 3-tier system where you separate concerns, and hence you can swap out different agents at every layer without disrupting the other layers. Because I think one skill that is going to be very important for anybody who is building an agentic system is to learn from the existing systems that have worked for decades. Anyways, I hope you found this video useful. Thanks for watching, and as always, see you in the next one.